In this video, let's talk about how to do churn modeling. Essentially, the problem at hand is a bank is worried about their customers leaving the credit card business. Now, essentially, this is a problem of people leaving the business, or you can say churn, or you can say attrition. And the data which we have has 23 columns, and as you can see, there's an attrition flag column over here. If we go to the description about this data set, the author of the data set or the provider of the data in kaggle.com says that please ignore the last two columns. Obviously, we'll do that, we'll delete them. So essentially what we have to do is we have to leverage this data to predict which customers are likely to drop off. And just something which you should know about, that there are roughly 10,000 customers and only 16.07% of customers who have churned or who have left the business. We have to do a prediction on who are going to churn out based on these features. Now, if you look at the columns again, you can see that the attrition flag has been described as if the account is closed, then it is 1, else it is 0, right? Or you can also say that the existing customer is 0 and attrited customer is 1. Then you have customer A, gender, dependent count, education level, marital status, income category, and so on. So I have prepared the data so that we can use it in building our churn model. If you remember my previous videos on using data frames or doing logistic regression in Julia, then you must be familiar with these packages. So we'll be using these packages. So let's just use them by pressing Shift Enter on this cell. Now let's load the pre-processed data. Now I have used that data set which had 23 columns to change it as per as my liking, because I need to work with a data set which is better for Julia modeling. And a lot of pre-processing I have done on R Studio because I'm more hands-on with R, and maybe in future I will find a workaround to do all my work in Julia environment and even show you the pre-processing activity. But understand that it is not rocket science. You can do it with just a bit of practice, and I need that much only. So over here you can say that they have omitted printing of 14 columns. So just to understand and have a feel of the data frame, we will just call out the names of the columns in this data frame. So you can see we have 20 columns. Essentially I have removed 3 columns which were not needed, 2 columns at the end which I had to delete because the author said that you do not need them, and I've also deleted the client number because we do not need client number for modeling exercise. And essentially if we have to build a complete model in which we are predicting for every client, then we'll have to use that kind of a client num, but that can be done at a later stage. For the model building stage we can leave it for a while. So we just have 20 columns. Attrition flag is essentially the most important thing. This is carrying the information whether the customer has churned out or not. Then the rest of the things are pretty self-explanatory. You can understand here that what exactly is inside attrition flag by doing summary stats on this. Write the data frame name, which is load underscore df underscore model dot attrition flag dot then column name, which is attrition flag. Now this gives you a hint that obviously this is a categorical variable with 0 and 1 values. So even if you had like some kind of a doubt that what is inside attrition flag, putting a summary stats will give you the idea that what exactly is happening over here. Now let's build the model. So if you remember the logistic regression model, which I've already discussed before in Julia, I'm using the same framework here. I'm making a formula. Attrition flag is the dependent variable, and gender, dependent count,
education level, income category, months on book, total relationship count, months inactive 12 months, contacts count 12 months, credit limit, total transaction CT, totals,
and so on are the independent variables. So let's use this formula which is stored in FM and use the data load DF model to build our logistic regression model, which is Logit. And right now you can ignore out the commented lines because that is something which I could talk about in a future video or later in this video, but as of now just ignore the commented parts. So let me first build the model using this FM and logit variables. So you can see that our model has been built over here. Now you may ask that why did we choose only these variables, because essentially we have like 19 variables apart from attrition, right? Now you can see that the formula of your logistic regression is written over here, and you can see that the formula does not have all the variables. Now how do we choose the variables which are to be used in the logistic regression? So I have done a bit of exploratory data analysis on this and built a kind of a correlation plot or a correlation matrix to understand which variables are related and try to eliminate out anything which is not really needed for analysis. So by looking at this chart, I can see that credit limit and average open to buy are related very strongly with each other, and even total transaction amount and total transaction CT. So I'll have to choose one of them. What I will do is I will choose credit limit between these two guys and total transaction CT between these two guys. Now you may ask why I did that, so I will cover that in a future video, but as of now, even if you had chosen the other one, your analysis would not suffer that much as well. So if you want to satisfy yourself further, you can look at the p-values for this and try to understand which of the variables is deciding your churn or attrition. Now let's try to predict using this model. So for prediction, we can just use the basic cutoff criteria that any probability which is less than 0.5 is not going to churn out, more than 0.5 or equal to 0.5 will churn out. So if we take that kind of a cutoff criteria, we will get an accuracy of 0.89, which is not bad, but considering that 86% of people are not churning. So a trivial model which says that none of the customers are churning is also 86% accurate. So let's go a bit further and make a confusion matrix out of this, and let's also calculate the recall and precision. Now, over here, the major concern here is recall. Now why recall? You need true positive upon true positive plus false negative, or recall to be higher. Why? Because even if you predict a non-churning customer as churn, it won't harm the business, but the other way is not true. So essentially you have to optimize on your recall. So your recall of 0.49 is not impressive. Maybe what you have to think about is whether this cutoff criteria of 0.5 probability was fair enough for you or not. So let's do a summary statistics on the prediction. Now what is prediction? Prediction is what is the range of probabilities as per your logistic regression model about the chance of churning out. So if I look at the summary statistics of this, I see that the minimum is 0 and the mean is 0.162, the maximum is 0.99, and the first quartile is 0.0105, median is 0.55, third quartile is 0.212. Now if I have some kind of a rough idea, that first quartile looks like some kind of a safe value. So any probability lesser than the first quartile, I should not expect them to churn out. So rather than having a 0.5 value, which is even more than the third quartile, I will take the first quartile number. Now you may say that this is not exactly scientific, but yes, this is an art. You have to get a feel of the numbers, that there are very less number of people churning out. So if you get a probability cutoff which is more than the third quartile, it makes no sense. So you have to have a lesser cutoff, maybe a first quartile or something like that, right? So let's choose the first quartile for now and plug it in here. This is our modified version of prediction cutoff. Now let's comment out this portion which we as of now do not need and activate these guys. If the probability is less than 0.010578, it's 0 or they are not going to churn out, and if it's greater than or equal to, they will churn out as per our model. So let's run this code. We can find the accuracy as well. So the accuracy is pretty low over here. The reason, let's understand why the accuracy has gone low. But over here we are not really worried about accuracy, we are more worried about recall. So you also have to look at the recall. So let's construct the confusion matrix, and let's also calculate the recall and precision. So you see the recall value is very high, 0.988, which means that we are doing a very good job about our KPI. Our KPI was recall, which we had to increase. And you can see that that is the main concern, that even if we predict non-churning customers as churn, it won't harm our business. So that's the idea over here. So this low accuracy is because of low precision. It's not good to have a low precision, because that would mean that we are accusing, or rather pointing out finger at customers who are not going to churn out, and then the people in the bank will have to go after a lot of customers who are not going to churn out. So this will increase a bit of cost, but you'll have to weigh down your cost and benefit. Benefit will be that if you go after the people who are supposed to churn and make them not churn, you gain something, but you stand to lose if you do not go after them and they ultimately leave your business. And the cost is that you have to incur a lot of customer chasing, because people who are not going to churn, even you will go to them as well because of your low precision. So let's do a bit of stress testing on this, right? And let's try to understand that what will happen if we pick different values of this cutoff. As of now, we have taken the first quartile, or 0.010578. What about if we had chosen different kinds of values, right? So what I will do now is, let's initialize 3 arrays which will store accuracy, cutoff which we need to choose for predicting churn or no churn, then recall and precision. Now what we will do is, we will take 251 values of our cutoff, and using those 251 values we will find out different values of accuracy, recall and precision. Now you can pretty much understand that what we are trying to do over here, right? We are increasing our cutoff from 0 to 0.25. Now you may ask, why 0.25? It's just our choice. We could have taken something else also, but 0.25 looks good number because that's slightly higher than third quartile, and third quartile is like a very upper kind of a limit, and 0 is like your minimum. So between minimum to a very high probability. And let's try to run this. Now why are we doing this? Because we want to check the sensitivity, or rather I should not say sensitivity, it might create confusion. I should say what will happen to recall and precision if we change the cutoff iteratively. So let's run this piece of code. And now let's plot the accuracy. So you can see the accuracy pretty much increases as we increase the cutoff criteria, which makes perfect sense. Now let's also add precision to this chart. Now you can see that precision also increases quite monotonously if we increase the cutoff value. What about recall? As expected, recall is going to go down if we increase the cutoff, because a lot of people who are supposed to churn out will be labeled as non-churning customers if we increase the threshold of our probability. Now let's just plot cutoff on this as well to get an understanding of the range of numbers which we have. So this lowest line is your cutoff, and you can see the green thing over here is your recall, right? Now I need a recall which is decent enough. So what is decent for me could not be decent for you. It depends from business to business. Now this blue over here is your accuracy. I need a high accuracy. How high? It depends obviously on the nature of business. And this orange thing over here is your precision. Again, dependent on the business, how high we need. But let's say I just want to have my own judgment. Let's say I am the bank owner or the bank manager. So I will require something which is reasonable, right? Reasonable meaning what? That see, my accuracy is kind of plateauing after this point. So I will be happy with this kind of an accuracy. And my precision is also increasing in this range. So I could have gone a bit higher, but I am okay with this. And my recall is steeply falling at this point. So I will try to control my recall around this region. So essentially I will choose anything around this region. Now what is the meaning of this region? This is between your 150 to 200, which means my cutoff, if you look at the code, is I minus 1 by 1000. So you can say that it is around 0.15 to zero point 0.2. So if I choose a cutoff between 0.15 to zero point 0.2, I will have good amount of recall as well as accuracy and precision. It depends from business to business what they consider a good recall, precision and accuracy. But over here I have tried to give you a complete picture, and obviously the visualizations could have been better, so you need to work on the visualizations part, and obviously the even pre-processing part can be showed to you, but I will obviously cover those aspects in the later stages of my Julia series. So do not forget to subscribe, because in this channel you can find content related to Julia, finance, economics, data science, mathematics and any kind of knowledge.